next week. So next week we have our ever so coveted mock AP exam, aka final exam. Yeah, thank you. All right, so I have you Monday, Wednesday, and Friday. So Monday is we have class and standard 2. They made that just for us to be able to take our multiple choice on that day. So day 1, or on the 8th, will be our multiple choice section. So we have, okay, I have to think of the new format. 60 minutes for 30 questions, and then 45 minutes for 15 questions. I'm going to write that up because that was too much. So 60 minutes for our non-calculator multiple choice. That's 30 questions. And then take a small break, and then it's 45 minutes for the calculator multiple choice, and that's 15 questions. So again, that comes out to 2 minutes a question for non-calc, 3 minutes a question for calculator. So this will take up both class and standard. Obviously, we'll take up all of standard. So we'll start off class with over homework questions, and then we'll start into this. So that's on the 8th, Monday. And then Wednesday is when we'll do our first spots. And so that's broken up into 2 calculator questions. And then 4 non-calculator questions. And this is 30 minutes and 60 minutes. So this will be our tight class time, and this will be not so crazy. So I believe government field trips on Wednesday, and I had a couple people. So let me actually write a list of who's going to be gone when, so we can figure out when to bring that up. Oh, I'm sorry. Thank you.
Was the FRQs just going to finish the first calculator section early, or without people on to the other one?
No, you have to sit and wait for the variants to finish. Yeah.
I assume we get both at the same time.
Yes. You have 30 minutes to do these 2. You spend your 30 minutes how you want. And then when you switch to non-calculator, you have 60 minutes to do all 4 of these, and you can go back to your calculator just so you don't need a calculator. Okay, so the 10th is our field trip. Raise your hand if you're going to be gone on the 10th. And then does anybody know that you're going to be gone on Monday? Okay, I didn't think that was a field trip. All right. And Peter, we already talked. Estelle, are you going to be here Monday?
Oh yeah, I told her that we're not going.
Okay. Sebastian.
I'll be going the 10th, I'm pretty sure.
Okay.
And what do we do Friday?
No, never mind.
That's okay. I'd rather you be here. Bless you.
Thank you.
What do we do Friday?
So Friday we're going to be doing just more review. So then, Estelle, you can make up this day on Friday, unless you want to do it. Okay, we'll talk at the end of class. We're going to figure it out. Thank you. Lily, are you going to be here on the 10th? Awesome. Okay. Peter and Estelle, you guys are difficult. Okay, we'll figure it out.
Okay.
Okay, so then Friday we'll just be doing more reviews, spring break. We'll come back, go over our AP mock exam, and then we'll review. All right, before I have you do your warm-up with the differential equations, I want to do something first with this. Sorry, let me bring up the right thing here. No. It's not fine, but thank you. Okay, so with our differential equations, we talked about when we have that initial condition. Okay, I'm going to bring up one here. I'm just bringing up what we did in class. Okay, we talked about when we have that initial condition, how to decide if we are taking the positive or the negative when we have that natural law of an absolute value. And so what we said is we take our initial condition, throw it in, and if they have the same sign, we keep the positive. If it's different signs, then we'll do the negative. I want to show you a different way for it that I think might be a little easier to understand, because I feel like when we were doing it, it was kind of confusing, like, well, there's 0, is that positive or is that negative? And so I'm going to show you the way that I used to teach it, because I think it's actually easier. I was doing some last night, well, technically this morning, and I feel like the other way that I taught it is actually easier to understand. So let's take a look at which one do I want. I want one that gives me a natural law. Okay, I'm gonna make one up. All right, so let's just say that we have dy dx equals x squared times y minus 4. So let's just say that our initial condition is f of 3 equals 5. Okay, I'm making this up completely off the top of my head, so hopefully this works out decently well. So what we want to do is, again, separate and integrate. So I'm going to divide by my y minus 4 and multiply by dx. I have dy equals y minus 4 equals x squared dx. I want to start separated. Now I want to integrate. I'm going to need to do a little mini u sub, but in the end our result would be natural log of absolute value of y minus 4. And this would be, let's see, add 1 to our exponent and divide by an exponent. So x cubed over 3 plus c. Yes. Okay. So we said last time, just take your initial condition, plug it in, see if your signs are the same or if they're negative. I think the easier way to do it, this is what I used to teach, is that at this point, as soon as you take your antiderivative, go ahead and plug in your initial condition. So I would have then natural log of the absolute value of my y value is 5 minus 4 equals, and then my 3 cubed over 3 plus c. Okay, take a look and see. When you take that initial condition and plug it in, inside your absolute value, is that a positive or a negative? Here we can see this simplifies down to a positive value. So thus, we don't need our absolute value bars to maintain that it's positive. So then we would keep the positive version of it. We can drop our absolute value bars and just leave it as our positive parentheses. If what's inside our absolute value is negative, then we would need those absolute value bars to make it positive again. So if what's inside is negative, then that means we need to negate what we have inside. So when you go to drop your absolute value bars, if what was inside was negative, then we would have to put a negative in front of all of it. Here, what we have inside is positive. So when I go ahead and solve for my c, let's see, so we get natural log of 1. Ooh, what is natural log of 1? 0. Ooh, this is a great problem. So I had 0, so c equals negative. Okay, so then when I go to do this portion here, where I plug in my c, I have natural log, and its absolute value of y minus 4. We said that what was inside our absolute bars was positive, so we don't. So we're going to take the positive version, which means we can just remove our absolute value bars and leave it as a parentheses here. Y minus 4 equals x cubed 3, and then plus c would be minus 1. Then from here, go ahead and solve. Again, if what was inside our absolute value bars when we plugged in was negative, then we would need to negate our equation. So honestly, when you go ahead and drop your absolute value bars, I would just stick a negative in front of it. But again, if you're not sure, I feel like 9 times out of 10 it's the positive, so just do the positive. Yes, it's
What do you mean by negate the equation?
So let's say that we had, let's say that was 2. Take 2 and put it in. We get a negative here, right? So then when I go to do this guy, I can't drop my absolute value bars yet. So value of y minus 4. Now keep in mind that this is now incorrect because I changed it. So I would do e of both sides, right? So I have an absolute value of y minus 4 equals e to the x cubed over 3 minus 9. So we want the negative of this. So then you would have negative of y minus 4 equals e to the x cubed over 3 minus 9. Does that make sense? So when we know it's positive, we can go ahead and drop our absolute value bars right away, or you can wait, drop them, and again, it's just going to be a positive. But when it's a negative, then you're going to have to, when you drop your absolute value bars, to negative of the whole thing. You could really just do negative of the other side. It doesn't really matter which. Okay, so your topic 6 is what you're going to do for your warm-up, since I forgot to have you do that for homework. I'm going to come around and check your topic 5. I'm going to just stamp the paper itself while you're working on that. And your topic 6 is the separable differential equations and spin fields. It's about the same length as 5, so hopefully it doesn't take too long. Okay. So our final topic for our first class is particle motion. And then we have the category of other types of questions. So our particle motion, there are only 3 questions. And then after that is our other category. So I'm going to have you do one of the particle motions and one of the other categories. Let me actually pull up the other categories.
Miss Margaret,
Yes.
one of the things we're looking at,
We don't get it all
what they did is our football team, they all got a bunch of labeled sex dolls. Ceilings in there.
Yeah, don't do that.
That is fucking
Never would it. It would just be weird. Alright. So I want to briefly take a look at our other questions. So particle motion, we've got acceleration, velocity, position, like normal. The other questions, so we took a look at the first 2 at the end of last class. And we talked about how there's some chain rules. Some chain rules, some product rules. And then I want to go ahead and just briefly talk through these other ones. So 2016, we had this funnel. This was not a favorite, but it really actually, students were making it harder than it actually was. So find the average value. That's pretty straightforward. And this is find the volume of the funnel. Students would write, my teacher didn't teach me the volume formula for a funnel. That is true, because we don't need the volume formula for a funnel. We're using calculus to find the volume. So they tell us that the funnel has circular cross-sections. If they say something about cross-sections, guess what you're probably going to use? Cross-sections. So they say that if we slice this horizontally, then we have circular cross-sections. And they tell us the radius of the funnel, so that's the radius of that cross-section. How do we find the volume of something? What do we integrate? The area of the cross-section. They gave us our cross-section is a circle. What's area of the cross-section? Or what's area of the circle? Pi squared. Oh, look, they gave us r. Okay, so they indirectly gave you the information. Instead of giving us a function on a graph and saying, okay, it's rotated, around yada yada line, find the volume of it. They instead gave us the shape and then gave us information about the cross sections in order to find their volume. So it's not that you need to know the formula for volume of a funnel, but rather you just use your cross section with that. Okay, and then part C, it's looking like it's probably going to be another related rates problem. So I feel like this is what, like the 3rd or 4th time we've seen this arise. So I feel like probably in recent years, the fact that they keep throwing related rates on free response, you're probably going to see related rates on free response. Alright, and then our next one after that, this is just this is just simply an implicit differentiation problem. So they give us an implicit function, they give us the derivative of it. They ask you to write the equation tangent line, find the points at which the line tangent is vertical. So we've done these texts before, and then it says to evaluate the second derivative at these points. And then I think it's our last one here, is an area and volume one. So this is what I would have described as one of our standard area and volumes, where they first have us find the area. So you do integrate top minus bottom function. So you apply individual and add them together. Then B, they tell us cross sections, so find the volume. So integrate your area of your cross section. And then C is the lovely type of right an integral. Oh wait, no, this was a rate, even better. So this one you had to do a rate at which the which your height changed. So this is kind of just our other category. Didn't necessarily fall into one of our 5 areas. Our 5 areas were differential equations, function analysis charts, function analysis graphs, particle motion, and what am I missing? What was the other thing we did? Function analysis graphs, particle motion, differential equations. Oh, rate in, rate out. Okay, so I'm going to have you guys take, we're going to do 20, I'm going to check in at 25 minutes again. I'm going to have you do 2 questions, so if at 25 everyone seems to be pretty much done, we'll stop and go over them, or we'll take the full 30. And the problems I want you to do is on our particle motion, I want you to do 2018 number 2. So it's that's the first particle motion, 2018 number 2. And then the second question I want you to do, you have to decide between the funnel or number 6. Do you guys want the funnel or this guy, the implicit? I'm hearing implicit. Yeah, so particle motion, so it says 2018 and it's question 2. So it should be the first particle motion, 2018.
And it has like
yeah, V of t is 10 sine. Yeah. So the particle motion 2018 number 2, this is a calculator question. Remember the first word calculator, so you already need your calculator. You just want there.
actually, we're all just. Yeah. There's no way to take on
Is there else I need to calculate? Okay, did we all find which particle motion one? Okay, so now I want your guys' input. Do you want to try this funnel one, or do you want the implicit? Funnel. Okay, we're gonna take it back. Funnel, raise your hand. What are we doing?
You want the funnel?
Alright, and then implicit, raise your hand.
The funnel or?
For the final?
Oh, implicit.
Right now.
Alright, implicit. If you don't want to do the implicit, you want to do the funnel, that's fine, but I'll go with the implicit.
No,
Okay, so 25 minutes, implicit, and our particle motion 2018 number 2. If you finish early, you can always do both the funnel and the implicit.
that's, I'm gonna do that.
All right. All right, I'm setting a timer for 25 minutes. So I'm checking in at 25. You have 30 minutes for 2 questions.
Oh,
I'm going to check in at 25. Yes.
That one,
So the first 2 problems are always calculator. So if it's a 1 or a 2, it's a calculator. After that, no. All right, let's go ahead and take a look at our particle motion first. All right, so again, if it's a 1 or a 2, then that means that it's a calculator question, because the first 2 calculator questions. This question's used a calculator. So they ask us to find the acceleration. That's pretty straightforward. Acceleration at 3. Make sure you have proper notation. Acceleration at 3 is equal to the derivative of velocity at 3. You have to label it, even though you're just punching through your calculator, you need to at least label that and then give your answer for that. B, find the position of the particle at time 3. All right, they gave me my velocity. How do I get back to position? Integrate. So you had a couple of options. I think perhaps the easiest way to go about this is we know that our position is equal to the antiderivative or the integral of our velocity. But they're looking for it specifically at time 3. What? So my position at 3, so this is, whoops. My position at 3, or my final position, is equal to my initial plus that change. So that means for us is our initial was our position at 0 plus the integral from 0 to 3. So my 0 should match with the lower bound. My final should match up with the upper bound. We're integrating velocity because that'll tell me my change in position there. So then we actually fill in our -5, find your calculator, for each calculator, find the integral, and then you can solve from there. Okay, evaluating the integral of v of t dt, you get to just punch that into your calculator. You get to punch both these into your calculator, actually. When we're doing the integral of the absolute value of velocity, what are we finding? Total distance, good. So then what is this guy doing? Good, displacement. Okay, and then they throw in a second particle, and they give us the position for that, and they ask at what time are the two particles moving with the same velocity. So if I have position, then my velocity is just equal to the derivative of my position. Oops. 2t minus 1, and then you just want to find where our velocity from above is equal to my velocity. So we're just, okay, so let's go and take a look at our answers for this. Okay. Alright, so part A, your velocity your acceleration at 3 was negative 2.118. Got 1 point for your answer there. So basically just 1 point for it. You need to have this labeled v prime of 3 equals a of 3. Make sure it doesn't say v prime of t equals negative 2.118. I'm pretty sure they don't give you points for that. Okay, and then part B, this is actually 3 points here. So you got 1 point for integrating your velocity from 0 to 3. You got another point for remembering to use that initial condition, and then 1 point for the final answer, which was negative 1.760. So 1 point for our integrated velocity from 0 to 3, 1 point for our initial condition, and then 1 point for final answer. Okay, questions on A or B or the points for it? Okay, and then part C. Alright, so you should have gotten for your displacement 2.844, for your total distance 3.737. Remember, you can literally just punch this into your calculator, make sure your absolute values are inside the integral, not outside of it. Alright, and then our first integral is the displacement over the time interval. They do want you to give this chunk where you say over the time interval. If you just said displacement, I don't know that they give you the point for it. You need to make sure you specify what time we're talking about. And then this one is the total distance traveled over that same time. So let's see our points for this. So 1 point for finding your integrals, and then 2 points for your interpretation. So 1 for interpreting this as displacement, and 1 for interpreting this as total distance. Okay. And then D. Should have gotten 1.57054. So 1.571 or 1.570. And so you got 1 point for setting your velocity they gave you to the derivative of the velocity, or the derivative position, and 1 point for your answer. So 1 point for setting these guys equal, and 1 point for your actual answer. I feel like this one wasn't actually too bad. Questions? Yes.
If you didn't do like v of t equals x like that, if you just wrote 2t minus 1 equals the velocity equation?
That would be fine. So like if you had this instead, that would be okay. Other questions? It's
When you write out like when for b, if you say like x of t equals the integral of b of t, that thing. If you write that out, is that enough? Or do you have to like insert like if you could put it in that?
so this is
Plus than
this is good to have. So you have plus initial condition.
yeah, but if you have the do you need the bound and stuff?
You are going to, so it looks like they give a point specifically for actually integrating it with the bounds. So although this is good to have, it looks like they give a point specifically for integrating with the bounds there. Yeah. Other questions? Okay. So show me with thumbs how I did with this guy. Hopefully particle motion isn't too bad. When we look at the other particle motion questions, let me zoom out a little bit. When we look at our other particle motion questions, they're asking similar types of things. So for 2017 5, what is it moving to the left? So that's when our velocity is negative. Find that the particles travel in the same direction, so velocities are the same sign. Find the acceleration. Is the speed increasing, decreasing, or neither? Ooh, that's a good one. What is speed? How do we find speed?
The absolute
The absolute value of velocity. So if we want to know when it's increasing, decreasing, or neither, we would look at the derivative of this. Derivative is positive, derivative is negative, or neither. So that would be a little different. And then find the position, so this made you go back again as well. Okay. And then our next one, big is velocity. Speeding up or slowing down. How do I know the difference between speeding up and slowing down? Who can explain that to me? Go ahead, Good. Speeding up, same signs. Think of like pushing, I'm walking and someone pushes me in the same direction, I speed up. Slowing down, someone's pushing me as I'm trying to walk against it, so. Okay. Final times which particle changes direction. So just velocity changing signs. Find the position of the particles that require the integrating again with the initial condition, interval or distance. So relatively similar concepts. There was one year that did not have a particle motion question, so that's why there were only 3 instead of 4. But it is, again, a pretty common topic to show. All right, let's take a look at our others. We'll start off with implicit, and then we'll look at the funnel. All right, so for our implicit here, they gave us our implicit function. They told us what the first derivative is. So we're an equation for line tangent to the curve at that point. So I just simply want to find my derivative evaluated at this point. Whatever that is, that's my slope. And just plug into the equation of the line. Find all coordinates on which the line tangent is vertical. If it's vertical, then that means that my derivative is going to be some number over 0. So what I'm really looking at is that my denominator equation or expression equals 0. Now, when we do this, we notice that there is both an x and a y. So that means I need to pull in a second equation in solving this system of equations. So we just go back to our original equation here. So I went ahead and just solved and said 3y squared equals x. And then I took this and substituted for x here and then solved. And notice it says find the coordinates. Sometimes they only ask for the x values. Here they wanted the actual x, y values. All right, and then C, evaluate the second derivative at that point where x equals -1, y equals 1. So you just simply had to find your second derivative using implicit with quotient rule. Okay, so let's go take a look at our points breakdown for this guy. Okay, so for part A, you should have gotten your slope was 1/4. They gave you a point just for that. Slope of 1/4. You do need to have proper notation where you say dy dx evaluated at -1, 1. And then our equation of tangent line, if you left it without it being subtracted or added over. So 1 point for finding our slope here, and 1 point for our actual equation. Okay, and then part B, Again, we want to take our denominator of our derivative, set it equal to 0. We get this equation here. And then we take our original equation, and we combine these together for a system of equations. And when we do that, we solve and get y equals -1. Substitute that back in, and we solve that x equals 3. So we have the coordinate point 3, -1. Make sure you put x and y in the proper location. Sometimes students will go -1, 3 because they just think the first thing they found is your x, y. So just be careful, don't lose an easy point like that. So our points for this, we get 1 point for taking the denominator and setting it equal to 0. So just doing that, not even solving it, but 1 point for setting the denominator equals 0. 1 point for combining the equations together. So it says equation in one variable, but that means it's just simply that you did a system of equations. So whichever way you substituted, that you combine the two equations together. So you got a point for that, and then 1 point for your answer. Questions on A or B or the points for it? And then C, let's look at this crazy implicit here.
Why don't they just use points rather than answers? Why do we have to write down all the other on the demo?
So you can get partial credit.
So you like, your work, you get one wrong, but your final answer is going to get points.
Possibly. So like for that one that we just did, you got a point just simply for saying your derivative equal to 0. Let's suppose that you messed up and solved and you said y equal 1, your answer's going to be wrong, but you could have still gotten a point for saying it equal to 0 and for the system.
I know mine, I didn't say like it was equal to 0, but I was going to get the answer right.
Make sure you say it equals 0. Yes. Okay, so here we had quotient rule. So our final answer for this simplified down to 1/32. Remember, we cannot have complex fractions. So if I would have had 1 minus 1/2/16, this is not enough for your final answer. You have to simplify this. So what we've done in class to simplify it is just multiply by 2/2, and then you would have gotten, let's see, what would that be? So 2 minus 1/32. That would have been fine as well. So we're going to take a look just to see how you do with this. We had to do quotient rule, and don't forget your dy dx's. Couple key things with quotient rule: make sure you have that it is minus on top, and don't forget your squared there. Okay, so our points for this. 2 points for the implicit differentiation. So probably if you mess up like the negative or you forgot your square, you probably still get 1 point. And then 1 point for substituting back in dy dx. So we had to use our dy dx that they gave us to put that back in so we could actually then plug in our numbers. And then it was 1 point for our solution. So 1 point for implicit, 1 point for taking dy dx from above and substituting it, and then 1 point for actual answer. Questions with C or the points? Okay, go ahead and show me with thumbs how we did with this guy. Okay, and then let's just take a look at our funnel real quick. The funnel, I feel like actually ended up not being too bad. Once you understand the idea that we're just doing integrating our cross-section area, I feel like it's not too bad. Alright, so find the average value of the radius of the funnel. Average value, you want to do 1/b minus a times the integral from a to b of my radius. And radius is a function of h, so it would be r h, dh. Make sure you're careful to match up the proper variables there. So we're looking, h is my variable that I'm integrating with respect to, so we're going from 0 to 10, so that's my a and b. 0 to 10. So then this would be 10 minus 0, which is just 10. And then we do have to actually take this function, put it in, and integrate it. We'll look at our answer in just a moment. B, find the volume of the funnel. So again, we talked about our volume is just integrating the area of our cross-section. And our cross-section for this is a circle, so our area would be, so circular cross-section, our area is pi r squared. So I'm going to keep that pi out in front, and then r squared. Now my r is this function here. So I'm going to go ahead and write it's r of h. I'm going to put brackets squared to h. And we're going again from 0 to 10. And then you have to actually evaluate that guy. And then C sounds intimidating, but it actually was a very easy related rates problem. So the funnel contains liquid that is draining from the bottom. At the instant when the height is 3 inches, so at h equal to 3, the radius is decreasing at a rate of 1/5 inch per second. So my dr dt, the rate at which the radius is decreasing, will be negative 1/5 inch per second. And then it says, at this instant, what is the rate of change of the height with respect to time? So we're looking for dh dt when this instant, so when h is 3. Okay. All right, so we need dr dh. Well, really, the only function we have to work with is our radius here. So let's go ahead and do dr dh. So I'm taking, actually, I'm going to do dr dt. That's not dr dh. It's with respect to time. It's decreasing the rate of 1 inch per second. H is not time, that's our height. Sorry, dr dt. Okay, so let's take the derivative of our radius with respect to time. I'm going to keep my 120 sitting out in front. And then my derivative of 3 plus h squared is just 2h dh dt. All right, so then at the time when h is 3, I would just plug in. Well, my dr dt was negative 1/5. I have 1 over 20. We're looking at when h is 3, so 2 times 3. And then dh dt, and you just solve for dh dt. So this one actually wasn't, I thought it would be more crazy than that. Okay, so let's go and take a look at our answers real quick in our final seconds before that bell rings. All right, I'm going to let you guys look at this while I pass out your homework. So did not forget about your homework this time.
We have a final.
That is true. It's a good thing that this will help you prepare. Okay, so your homework is the Lucky 13. So these are 13 types of problems that students commonly make mistakes on. So what's lucky about it is that now you know what mistakes not to make. The key is up on Blackboard, so just as you go through check answers with the key. Like that whole thing.
Yeah, it's good.
Look at that whole thing, just good. The difference, so like the first response, pretty much, so this is the AP exam made by college board, not by me. So most likely their first response will be just different actions.
Which test is from what year?
Like this year, like they have released a secret test that only the people are
They always say secret.
I tried to Google search the problems.
But after this, when we started go,
Like that.
we found all the FRQs.
Really?
Yeah.
That's not good.
And then he said, for each one you find, well,
Well, that won't happen for me, but
I got
Do we start the,
what is today? Today's Tuesday? Yes, it's my birthday. Yeah.
do we start the code?
Do you sell what?
Do we start the code?
Oh yes, this is an AP exam, AP curve. They give us the grading rubric and everything.
Okay. On the
Yes.
AP exam, like what percent translates to like a 5 or?
Approximately, okay, I wrote this down. It changes year to year.
Okay.
We're going to lab one.
Okay.
This is not like this.